LT1 of this unit, simplifying expressions using properties of exponents, is basically just going to go over a ton of different rules for anything with exponents. This video is kind of going to be structured like with a short little investigation, then the rule, then practice. Then a little investigation, then rule, and then practice. So it's going to go through all of these different properties of exponents, kind of one by one, and practicing how to use them. Basically, the best way to learn these and just get better at them is kind of just by doing them. So hopefully the investigations will help you kind of see why, instead of just like, well, here's a rule, some guy a long time ago made it up, now memorize it. Okay? So this should help you kind of see like, oh yeah, like I see that, that makes sense. So the investigation for this one, rewrite each product below in expanded form and then rewrite it in exponential form. So right now it's in exponential form. If I expand this, 3 to the 4th means 3 times 3 times 3 times 3. Then I multiply it by 3 squared, which is just 3 times 3. That's the expanded form. So I got 3 times itself 6 times, which then if I put it back into exponential form is just 3, and you've got it times itself 6 times, so it's 3 to the 6th. Okay, pretty self-explanatory. For the next one, x to the 3rd means x times x times x, and then we multiply it by x times x times x times x times x. So if we count them up, we have 8 x's. So in expanded form, it's x times itself 8 times. In exponential form, it's 8x to the 8th. All right. Part C. So many 10s. All right, 10 to the 3rd. 10 times 10 times 10. And then times 10 times 10 times 10 times 10 times 10 times 10. So we've got 10 to the 3rd, and then times, here's 10 to the 6th. So total we have 10 times itself, 9 times, so this is 10 to the 9th in exponential form. Okay, so if we kind of look at what pattern have we seen here, describe a way to find the exponents in the final expression without using expanded form. So what we want to try to avoid is having to write this out every single time, or having to write this out every single time. So we can look at a pattern and say like 3 to the 4th times 3 squared equals 3 to the 6th. And that's where this rule comes from. Okay, so for any two numbers, b to the m times b to the n equals b to the m plus n. So in this case it was 3 to the 4th times 3 squared. So we just did 3 to the, and if I write this kind of in between step, this would be like 3 to the 4th times 3 squared equals 3 to the 4 plus 2, which is 3 to the 6th. Okay. So the last part is just to practice these. More examples. So 2 to the 7th times 2 squared, that'd be 2 to the 7 plus 2, which is 2 to the 9th. This would be t to the 1 plus, t to the 1 plus 28th, which is t to the 29th. 199 to the 3 plus 9th, which is 199 to the 12th. And then the U try, that's kind of like our before class. We're not going to have a before class. So all of the U tries that you see will be up to you once this video is over. Okay, so that one's for you to try in just a few minutes. Or you can pause now if you want to do that. It doesn't matter to me. The next one. Now we're looking at 4 to the 5th, and then that whole thing inside the parentheses to the 2nd. So if we rewrite without parentheses, this would be 4 to the 5th times 4 to the 5th, because I'm squaring it. And we just looked at what do you do when you have two things with exponents times each other, you just add the exponents. So this equals 4 to the 5 plus 5, which is 10. Here we have x cubed times x cubed times x cubed times x cubed. So basically we've got two of the problems from the previous rule. So we've got this multiplication property that we just looked at twice. We've got x cubed times x cubed, which is x to the 6th, times x cubed, which is x to the 6th. So that is x to the 12th. Or if you want to think of it like x to the 3 plus 3 plus 3 plus 3, that equals 12. This last part, x times y, we are cubing it, so we got x times y times x times y times x times y. We've got x to the 1 plus x to the 1 times x to the 1, so this is x to the 3rd, y to the 3rd. All right, and then that leads to the power property, which says that b to the m, that whole thing to the n, is just equal to b to the m times n. Or if you have a b to the n, it's equal to a to the n times b to the n, right? Okay, so that kind of goes one way and then backwards. These two kind of undo each other. So you've got x squared to the 4th. This would just be x to the 2 times 4, which is x to the 8th. Here is like our second type. So we've got 3x squared. That means I'm going to do 3 squared and x squared. 3 squared is 9, so this just is 9x squared. 2x squared to the 3rd. I'm going to do 2 to the 3rd and x squared to the 3rd. X squared to the 3rd, I multiply the exponents and get x to the 6th. 2 to the 3rd is 8, so 8x to the 6th is the most simplified answer. Then we've got the u try, 5t to the 5th, that whole thing squared. Moving along. Write the numerator and the denominator of each quotient in expanded form, then reduce to eliminate common factors. Rewrite the factors that remain with exponents. Okay, so now what we can do is we have 5 times 5, 9 times up there, 5 times 5, 6 times down there. So I can start to cancel these out. And I'm left with 5 times 5 times 5 on top, which is just 5 to the 3rd. Over here, 3 times 3. Again, go through and cancel out. So I can cancel out a 3 and a 3. 5, 5, 5, 5. On the top, I'm left with 3 times 3, which is 3 squared times 5. And then we can go further. So you can say, like, 3 squared is 9 times 5 is 45. I'm just going to leave that off for now. Again, go through, cancel. You can cancel out 2 4s there. You can cancel out an x and an x and an x and an x. And you're left with 4 times 4 on the top and x times x times x, so 4 squared times x to the 3rd. Okay, and if you look at kind of what pattern we got, we're canceling out the whole bottom. So basically we canceled out 6 of these 5s and we're left with 3. So that kind of leads to the division property for exponents. If you have b to the n over b to the m, your simplified form is just going to be b to the n minus m. Okay, so in this example down here, we have 6x to the 9th over 5x to the 4th. So I'm going to just pull out that 6 over 5, and now I'm just going to worry about the x's. So I have x to the 9th over x to the 4th. That means I have x to the 9 minus 4th which is 6 over 5x to the 5th. Right here, I've got 3x squared times 8x to the 4th, which is 24x to the 6th, if you remember the multiplication property that we learned at the first one in this video. X squared times x to the 4th is x to the 6th, over negative 4x cubed. My x cubed and my x to the 6th are going to cancel down to just x to the 3rd. 24 divided by negative 4 is negative 6, so my final answer is negative 6x to the 3rd. In this next part, okay, this kind of looks like, this is called scientific notation. You're going to learn this next learning target. But we've got 7.5 divided by 1.5, which is just 5. And then we've got a 10 to the 8th over 10 to the 3rd. So if I'm canceling out a 10 to the 3rd, I'm subtracting 8 minus 3, which is 5. So really I've got 5 times 10 to the 5th as my final answer. And I just got that from 8 minus 3 is 5. So that's the exponent on the 10. There's your you try for before class next time. And then here is negative and 0 exponents. Okay, so for each one of these, if you've got a negative exponent, it's just going to take that b. So if you have b to the negative 3rd, this is really just going to end up being 1 over b to the 3rd. Okay, and we can see that in this first example, we're just dividing. This would be y to the 7 minus 2, which is just y to the 5th. That's something that we looked at on the previous slide. Here, though, is where we start to get negative. So you'll do 3 to the 2 minus 4. It ends up being 3 to the negative 2. So if we have 3 to the negative 2, like it says down here, this just ends up being 1 over 3 squared. 7 to the 4th over 7 to the 4th. 7 to the 4 minus 4, which is 7 to the 0. Anything to the 0 is just equal to 1. Okay, so it doesn't matter if it's like 7 to the 0 or 70 billion to the 0. Okay, it's always going to be just equal to 1. The last part is your middle example here. So you've got 2 over 2 to the 5th. So this is really like 2 to the 1. This makes 2 to the 1 minus 5, which then gets us 2 to the negative 4, which is 1 over 2 to the 4th. Okay, so anytime you have a negative exponent, you're basically just reversing it and making it 1 over whatever that was to make it a positive exponent. So down here, 7 to the 5th over 4 to the negative 7. This gives us 7 to the 5th over, and then 4 to the negative 7. We just rewrite that as 1 over 4 to the 7th. And dividing these two, if you're dividing these two, it's really just going to give you 7 to the 5th times 4 to the 7th. And then you can go through and actually figure out what 7 to the 5th and 4 to the 7th are if you want, but for now, don't worry about it. Negative exponent here, that means if you have a negative exponent in the denominator, you're just going to flip it back up to the top. So this is really just going to be 25x to the 8th. And then over here, since both of them are negative, I'm going to flip both. So this is just going to end up being 2 to the 8th over 5 to the 3rd. So for the u try, you've got x to the negative 4th. So go ahead, if you haven't done them already, go ahead, finish up all those u tries, and then we'll talk about them in class.